All right, welcome to our next episode. Today we'll be talking about how you can use Rx to actually do really powerful, complex queries. And we'll show you event processing in detail. So again, we're going to come back to this, what Rx is. It's observables, the representing asynchronous data streams part, link, which is the query part, and scheduler is the parameterizing concurrency part. Today we're focusing on the query part, or the link aspect. So here's a problem. I have a stream of stock ticks. Actually, if you did the last challenge, you'll know where that stream of stock ticks came from. And now you want to find a 10% daily increase in price in that stream for a particular symbol. How can we do that? What we can do is use link. So here in this example, we have Microsoft and Intel stock. We have this stream of all these prices coming along. And at the end, we have this uncompleted message here. And what we're going to do, first of all, is group the symbols, group the stock quotes by symbols. So we'll use a group by, and we'll say by the symbol. And what it does is it takes the Microsoft ones and the Intel ones, and it then splits them into separate streams. So now we actually have a stream of streams. And so that would be represented by iObservable of stock quote. And so, for example, on the outer one, it's a stream really of groups, which the groups consist of a key, which is the symbol, as well as the stream, which is the data. So in this case, as soon as the first Microsoft stock quote appears, it creates a new group with that symbol, and then the actual data stream has all of those stock quotes in it. When the first Intel one occurs, then it has the same pattern. If there was a third symbol, it would occur where it did. And that's kind of how the group by works. The next thing we want to do is actually take each of these symbols, each of these stock quotes and by symbol, and actually aggregate it with the previous day. You can use buffer that takes the count arguments. In this case, I want a rolling buffer of size 2, which is the previous day and the current day, and actually roll it by one stock quote each time. And so you'll see here that I combine these two together, these two, and so on, and it will do that within each stream. So now I have grouped and I've gotten the previous day with the current day. You'll notice that the first stock quote disappeared, and that's because there was no previous for that day. And so now we have the previous and current. We can do some sort of calculation to figure out if there's a 10% increase. In this case, we'll do a where, which is a filter, and we check to see if the price is increased by our threshold amount. And the first one has not, this one has not, and so on. And all we're left with is the single one. And what we can do now is take these groups and actually reduce them back to a single stream. In this case, we use merge. There's actually several ways you can reduce. Merge is one of them. And merge will take all of the individual things and from all the different streams. So if you have a stream of streams, it'll actually push them back into a single stream with the values occurring wherever they occurred in the inner streams.
So you're flattening the streams. Right?
Exactly. We flatten them back here. And now we're just all left with is the Microsoft stock, 27.96 and 31.21, which is our 10% price increase. So here's kind of how the query would look. We have from tick and stock ticks. This is our source. Then what we do is we group it by the symbol, and we group it into the symbol stream. Then we say we'll aggregate it by a rolling buffer of size 2, and we roll it by 1 each time. We call that window. And then we apply the price filter, and we call that the increase. We check to see if the increase is greater than 10%, and then we project out the key, which is going to be the symbol, and the increase amount. And this is kind of our complex event processing query. So let's take a look at a demo of that. We've seen buffer in one of the earlier ones.
Yeah, we've seen buffer, and actually, to notice the type of the window that we saw here was an iList, right?
That's right.
An iList of T, or in this particular case, an iList of stock quotes, most likely. And those values that you can actually have in there, you can do all sorts of link to objects queries on top of them as well, right?
That's right. And for all the buffer ones, there's also windows, which are iObservable of iObservable, and they have the same set of overloads.
Yep, exactly. So maybe we should take a look at some of the windowing capabilities here, right?
Yep. Windows, group bys, that'd be great.
So let's actually create a new project, and this time let's just do a console application and just create some very simple stream here of data that we'll group by some key, and then we'll also do some windowing.
By console input, maybe.
Console input, okay, sure. Let's do some console input, and let's group the console input based on things that the user actually writes, like starting letters or lengths or something. So let's do static IEnumerable of string, which is basically just a loop that will produce the values that the user is typing at the console. So let's do this thing, call this thing get input, and I'll just use C# iterators here, while true yield return console.readline. So basically what this does is if you do a for each over get input, it will actually block till the user writes the next thing at the console, and it will actually pump that out to the enumerator, and you can actually just iterate over that. So just to show that this really works, for s in get input, console write line s. Now I actually have an enumerable source, of user input, right? The user can write hello world and so on, and it just comes out. Of course, I don't want to do things with enumerables in this case. I actually want to make actually a timeline out of that of events, like the user types something, and it's as if an event arrives in the system, right? It's a very good, mock input of data. In reality, it could come from the network or anything like that. So instead of doing a for each loop, let's actually do toObservable on the IEnumerable sequence, which gives us an IObservable of string. So instead of doing a for each here, let's just take get input and do, var source equals get input toObservable. And the toObservable lives in system reactive link.
Want to do it on another thread too.
And exactly, we want to basically do the toObservable, which basically iterates over the IEnumerable, somewhere, such that we can do event processing in the meantime, like make the whole thing asynchronous. So we're going to introduce some concurrency here, basically designating, the location on which this, for each loop over get input actually works, which will block on user input. So we don't want to be blocked in our query. So let's do scheduler, and let's say, for example, let's do a new thread that's basically sitting there and reading things from the console. So as soon as I do that, I can of course subscribe to it and just, we should see exactly the same piece of code, but I don't want to block here. Let's do console.
You can't do a read line, but you could do a for each for the subscribe.
Oh, I can do a for each?
For the subscribe.
Yeah, oh yeah, I can do for each here, which is a blocking operator. So this one actually is not like subscribe would immediately terminate here, because it's asynchronous. For each will actually wait till the end of the stream, but there is no end of the stream. So I can actually write things and it still works, but now it has actually gone to IObservable sequences. So now that I have that sequence, let's actually group things by user input. So let's say that, var s equals from, s in the source. Let's actually group s by, say for example, s.length into g. And now I actually have, an IObservable of iGrouping, or iGroup observables, iGrouping observables, that contain the key, which is the length of the string, as well as, the values that sort of fall into that bucket of the same length. So if I would actually give here like Wes, Bart, and Eric, I would create two groups. The group of people with, names of 3 letters, and then the group of people with 4 letters. So let's actually group this thing into G, and let's select out, for example, well, actually, let's just select the whole thing, right? Let's just do something like this, right? So now I have the result sitting here. If I do result for each, let's take a look at what comes out of here. Like, what's G look like? As I said before, actually G will simply be something that contains a key. So you see the key will be the length here. So I can do console write line of g.key, and I will say new group with length equal to g.key, like this. And then I can listen to that group, which you can do by doing a subscribe. So you can basically say, I have a new group that has been created. Let's listen to that particular group and do things with that. So let's actually do console write line here, and let's do, x goes to, which is, the name of the user actually coming through. And let's say console write line plus x, and I can of course use is g.key again to sort of say like, which group it's member of. So here you will see Wes member of 3, Bart member of some other group, and so on. So now all those groups are actually going in parallel here. So when a new group comes in, we actually print that to the screen, and then we subscribe to the other group. If you would do the same and link to objects, you would just have 2 nested for each loops, right? You would have a for each loop over every group, and then you would have a for each loop over all of the elements. I don't want to do a for each here because I might introduce too much blocking, so I'm doing an asynchronous subscribe inside the group handler. So let's do Ctrl F5, and let's see what comes out. When I enter Wes, you see that a new group was created with length 3, and we see Wes is a member of 3. I can now enter, for example, Bart, and then you see a new group is created for people with length, name length of 4. I can put Eric in here, and then you see, like in this particular case, you see no new group is created, but we're still listening to that inner group, and we see the new
Ben
member
next.
coming in. What?
Ben.
Okay, yes, I was already
I need
thinking
someone else
like
in my group.
somebody with 3 letters. Maybe you want another one. So
N, A.
okay, more people with 3 letters
And
than I
without
do.
the E.
Okay, so here we see, we can do N with an E, and now we have gained somebody in our group as well. And then ultimately, let's do Savas, and then we get groups with length of 5. And so you see that new groups are actually being produced whenever you do something over here. So basically, now we're listening to multiple groups, which is basically created by doing group by, which produces an iObservable of iObservables. We have other operators that do something very similar, like the buffer operators
And
and the window operators. So let's actually do something like a window operator, where we basically listen to events coming from the console again, but now we'll actually chunk them up in groups of, say, like 3 inputs.
Yeah, that's great.
So let's do var result equals source dot, and let's do window to basically show something that's very analogous to the grouping operators. So we have a number of window overloads, as you can see over here. You have an overload that takes in the count, so I can, for example, say 3, which creates windows of length 3 that are consecutive and non-overlapping. So you get the first 3, then the chunk of the next 3, and so on and so on. You can also specify time spans, like if you want to listen for input, for every second, for example, then you get windows of length 1 second. You can also specify the more complex ones that actually have closing selectors. We'll not talk about those over here, but that allows you to actually have some observable sequence that basically delineates when the window has to be closed.
Yes.
So that's actually a higher order composition here. We also have things like window that take in account and a skip. If you want the buffers to overlap or be totally disjoint, you can actually use those skip operators.
And by default, this count
yeah.
equals the skip.
By default, indeed, the consecutive windows are done by count and skip being the same, right?
Yes.
So it's actually skipping from the beginning of the window, right? And you can actually pass in some other ones like, time span and count, whatever comes first, and so on and so on. So we have a lot of those, and we also have parameterization on the iSchedulers for creation of timers. Let's simply say, we'll create windows of length 3. As I do that, I get an iObservable of string, where the outer one basically indicates that a new group has arrived or a new window has been opened. You can listen to the inner window, and the inner ones basically contain the elements that actually fire. So let's do res for each again. So we're listening to the windows. Whenever a new window is created, I will actually do console write line, new window created, and then I will basically listen to the elements in the window, and I will simply do console write line of the elements inside the window. And so this looks very, very similar to the group by that we've done before, which was also an iObservable of iObservables, right? Mm-hmm. So.
And again, the only reason why we're using the for each here is because we don't want the main thread to go away.
Exactly, yeah. I could also, do a while true underneath that, right?
Yes.
So let's actually execute that. You see a new window has been created, even though I didn't put any input on the screen yet, simply because, well, we're at the beginning of a boundary of a window. And now you will see, hello world there. You see that those 3 values were actually produced inside that window, and then a new window was created. So that's actually the non-overlapping windows that you see here. Now if I would do window 3,1, you would actually see the first 3, then the second to the fourth, and so on. So you would see a sliding window, and you would see messages actually being produced into multiple windows, yes. Right? So I could actually do something like var I equals 0. Whenever a new window comes, I will increment my counter. I will say that the window that I've created has number I, right? And I will have to be a little careful here with closures. I will have to say, I will capture it here. But then, for every value that actually comes inside the window, I will say, let's say I will just put in here the x plus in plus j. So now basically for every window that's created, it gets its unique ID. And then those IDs are basically put on the screen for all the messages that come in. So you will see that messages that I have sitting here will actually be projected into multiple windows because the windows overlap. So if I do Eric is actually sitting in Windows 0. Now I have a new window 1 created which overlaps partially with Windows 0. So if I put Bart here, you see Bart is both in Windows 0 and 1. If I introduce Wes, he's actually in 3 windows. If I now introduce Gert, for example, he's actually in 1, 2, 3. So you actually see that the windows are sliding now, and values can actually appear in multiple windows. So that's actually what's going on here. Now you can also do one more thing. Instead of doing window, in case you don't want to listen to the window as soon as it's created, you can also do buffer. And buffer is basically a way to create persistent windows, right? It's basically at the end of the window, it produces an I-list of all the values that were part of that particular window.
And that's the important point, is it happens at the end of the window.
Exactly. Yep.
Yep.
So with that,
that's very good. So let's look at the challenge. This is one of my favorite challenges, actually. And this challenge actually builds off the previous challenge. So last time we took the schedulers and we were able to create a stream of stock quotes. Now, spoiler alert, you're going to see code here that could be a answer to that. All right, so down here, what we want you to do now is to modify the query that you previously had, which just got the Microsoft closing price and date, and now modify it to give you to compute the average high and average low over the past 5 trading days, as well as the current close and the date. And so go off and write that query. If you're able to do that really easily, you can also try things like, instead of doing the past 5 trading days, do the past 5 days and see if that works out for you. And have fun, write some good queries, and share them online. Thank you.